Hello, my name is David Giles and I work for Hitex Development Tools, and this is test case design using the classification tree method part 2. It's a worked example using the TESSY unit testing tool from razorcat. This is the example which was shown in part 1. If you remember, we have two input variables, ADC value and my local humidity. So just to recap, we have two input parameters and we have one return parameter. If you remember from part 1, we had identified that there were two test relevant aspects to this function under test. Those two test relevant aspects were the two input parameters. As you can see here, one is an unsigned char and the other one is an enum in the range of 0 to 0xff. And the ADC, the expected values for the ADC is between 0 and 3ff, which defines the first valid class. Values outside of here fall within what we call the invalid class range. So we have invalid boundary values and we have valid boundary values. So the second parameter, we've kind of elected to have separate classes for each of the enums. So E dry, for example, has a value of 0. We call that valid class 2 or VC2. We have E normal, which is VC3, and we have E dry, which is VC4, which has, these take on the values of 0, 1, 2 respectively, and anything that's any other value other than 0, 1 and 2 is basically invalid. So all the numbers between 0x03 to 0xff fall within a class which we've called IVC2 or invalid class 2. Similarly, we have some boundary values. In this particular case, the 0, 1 and 2 are also boundary values as well as discrete classes, and we of course we have some invalid boundary values as well of 3 and 0xff. Okay, so now we're actually into TESSY, and here just to quickly show you what we have, and the environment that we have set up is for the TI Code Composer Studio, and the source code which I've selected, which is called temperature_calculator.c. I've basically opened up the module, and TESSY has correctly identified that within that C source file that there's one function called temperature converter, and again we can have a quick look at the interface for this. We've also identified that there's one return parameter. So along this icon bar which you see at the top, there's one which is for the classification tree editor, which is an integral part of TESSY. So what we have here is the name of the test objects, which is called temperature convert, and now I have to start the process of building a classification tree for that function. So we do this initially by right clicking and then clicking on new and adding a new classification. In this case, I will kind of just start to build up all the classes. So we have ADC count, which is one of the test relevant aspects. I'll ask myself a little question here: is it invalid or valid? And you can see that we now have another box. So now I'll do a new class. So I'll have a new one called valid class VC1, and I'll have a new one now, a new class which is for invalid, which is called invalid class. And these IVC1s and VC1s, these relate back to the PowerPoint presentation which I showed you, where we'd kind of subdivided the parameter into valid classes and invalid classes with boundary values, etc. Okay, so new classification. So now I'll ask myself another question: where in the class, question mark, and I'll then add some more in. Lowest value boundary VB1, and these are just kind of text representations of the tree. Highest value VB2, which is the highest boundary value, which is 0x3ff, and then we'll have some in the middle. New class, so we'll call this one mid-range. New class, and we'll kind of have typical high, so that would represent a value of maybe of 0x300, and we'll have a typical low. These are obviously numbers within the valid class range, so that one would represent something like 0x100. And for the invalid class, for the raw ADC count, again we kind of have to build up some leaf classes for this. So where in range, and then we'll have a new class which is invalid boundary low, and that's has a tag of IVB1. Right click, new class, and we have invalid boundary high, so this would be OXFFF. Yeah, so that's IVB2, invalid boundary 2. So as you can see, for ADC now, I've subdivided this down into two leaf classes, one of which is called valid class VC1 and the other is called invalid class IVC1. And for the valid class values, I've subdivided down into 5 items which I'm going to use within my test, and for the invalid class I've subdivided that down into 2 other leaf classes which will have values on the boundaries, so the invalid boundary IVB1 and IVB2. We do a similar exercise over here for the other test relevant aspect, which would be humidity valid or invalid question mark. So now I can tidy this picture up. I can highlight all of it, and I can click on the arrange icon symbol which you see up there. So let me just do this a little bit at a time. There we have it. Okay, so what we have now is a tree which represents each of the test relevant aspects, and also the leaf classes and subclasses which are below that. I now need to start to create some test cases for myself and create a combination table. So if I just press the insert key here, and we can see here that I've generated 7 test cases, although I still haven't assigned values to the to each of the classes. I'll do that first of all. So if we come up into the tabs at the top and click on view, and basically can pull up a list of all the variables that are associated with this classification tree. You can see TESSY has given us the 2 input variables, which is my local humidity and ADC, and what I'll do is I'll grab the ADC value and drop this on top of this class which you see here, and similarly with my local humidity, I'll grab that and I'll drop it onto the tree. What you've noticed now is that each of the classes and leaf classes has a small grey dot appear, and this means that no value has currently been entered against it. So if I click on this lowest value boundary VB1, here we have the descriptions box, but now if I come across over to the variables, you can see that the variable has actually been listed. So I can double click this, and I know that the boundary value VB1 has a value of OX0, and you'll notice that the little grey dot has now turned yellow. Similarly for the other ones, I know that the highest value that legally that we're kind of allowed within this class is OX03FF, and similarly here the mid-range one, I can type it in hexadecimal, so it's OX0200, which is the mid-range on the ADC. I can input a value for typical low, which is OX100. Enums, with enums you can actually give it the name of the enum, in which case it's called edry. I could also use the actual value which it has, enormal and edry. Okay, and for the invalid boundary ones, obviously we don't have an enum generated for them, so but we know that value to be 3, and the maximum value that's allowed to take is OXFF, and click on OK. So now what we have is actual test data for each of these different test points, and so I'm going to create a test case number 1, which is basically I'm going to call cold and normal humidity, and I'm going to select from here an ADC value of 0, which is the represents the absolute minimum that ADC can generate, and I'm going to combine that with a humidity value of normal. So you can see within this combination table, it's very easy to see the test case being described graphically. It's very simple to see that I have a test case which uses the boundary value for the ADC with my local humidity enorm of enormal. I generate another one here, so we could call this one hot and normal, and this time I'd use the other highest value, which is OX3FF, which obviously the ADC is measuring temperature there, and again I can have a test case with the two together. And similarly I can go through this list. Typical summer is the name of this third test case, so I'd choose a value of something like typical high. Being as it's a British summer, we would have something called EDAMP as a test case. I can have another test case, for example, which is it's called something wrong. In this particular instance, I can use an invalid value for the raw ADC count, and I can use a value, for example, for an invalid value for humidity. So you can see that this one here is we've basically presented the function under test with some garbage information, but we may want to test for that as well. So you carry on to build on all the test cases, and I can basically click on this TESSY symbol here, and what will happen is all the test data which I've put within this classification tree will now actually be exported to TESSY. So I click on OK, and when we come back into TESSY, you'll notice that we now have 4 test cases which have been generated. Okay, so TESSY has now exported the test data, and you'll notice that the test cases have now appeared inside this dialog box. And if I double click on, say, test case number 1, you'll notice that within the test data editor that the 2 values have been provided to us from the classification tree editor. So we can see we have short ADC as a value of OX0. What we've not given TESSY so far is the return value. So if we had a value of 0 and an E normal value for my local humidity, that should return a value of minus 100 degrees. Similarly, we're kind of filling all the other return values. Test case number 4, you'll notice that here in the specification table, information that we've provided in the text boxes within the classification tree has actually been brought through for us as well. So you can see for raw ADC, is it valid or invalid? And you can see we've got invalid class IVC1, and where in the class it's invalid boundary high IVB2. And similarly for humidity, we have some information. So we can see that by looking at the specification, we have some textual description of kind of what's going on. I'll click on close, and now I can run the test. So I highlight all 4 of the test cases, click on the razorcat button. I'll turn the instrumentation on as well, and we click on execute. And the tests have now been executed, and you can see that we have 1 passed test case and we have 3 failed test cases indicated by the red icons. What TESSY is able to do for you is to generate a report which includes the CTE graphic as well. So if I click on this icon, report generation, HTML format, and you can see the HTML output report actually includes the classification tree and the combination table. You can see that we have 4 test cases and the combinations that we've used from each of the different classes and boundary values. So that's a short introduction to the classification tree method and how TESSY can use that with its CTE editor to generate test cases and execute test cases. Thank you for listening to the presentation today. If you're interested in finding out a little bit more on TESSY and you're from UK or Ireland, then please contact myself, David Giles, on dgiles@hitex.co.uk, or for other regions around the world, then please contact my colleague Frank Buchner, frank.buchner@hitex.de. Thank you.